And the TCAD tool is basically a virtual environment of the fab. Basically, in this in this tool, you're just creating a single device or a multi-device or converting a mixed mode simulation, just creating a device convert to a circuitry. These are some of the basic steps. You just follow it and just creating a single device on a TCAD tool. Basically, starting with the device drawing, the every step is discussed in detail in the next slides. And the After the device drawing, you just going to the massing part. Basically, you just cover all the little and the thin film, just covering the mass. And after the massing, you're just going to see here the simulation part, simulation setup is done. And after the device simulation, and just see here the 3D visualization, result extraction, and the parameter extraction. These are some important and the usable parts for creating a device on a TCAD tool. This one is in the TCAD tool. Basically, the device drawing further divided into three parts. Basically, the first part is shown here. Just this is the working space of the TCAD tool. Is This is working basically creating a drawing window, GUI window, graphical user interface. This is used for easy to use for the new user. And the another type is creating the device using scripting, and third one is using a layout. Using the three methods, you just create your own device on your TCAD tool. Now, what is the importance of massing and why we need of massing in the TCAD tool? This is the accurate representation of the device in the geometry, numerical solution of the partial differential equation, handling the various in the physical properties, enabling the convergence and stability, and visualization the simulation results, and supporting the advanced simulation technique. Basically, you see here, this one is the meshing here. Just uh, look like a net part here. Spider net is look like this, and this one is the meshing here. This is the multiple lines crossing, intercrossing the, creating a net like structure. After the meshing, you just go to the simulation setup. Basically, the advanced setup, boundary conditions, material parameter, physical model, solver option. These are some important parameters you're going to design and simulate the device. You're just using these some simulation setups. Now, you just go to the modes of analysis, like as a DC steady state sweep. On the DC steady state sweep only, just going to simulate the device on uh, like as a 0 to 5 volt and 5 to 0 volt. Just going to a simple sweep, only simple sweep, like as a only start with the 0 to 5 volt and 5 volt to 0 volt and 0 to minus 5 volt, minus 5 volt to 0 volt. Just going to this. And after that, just going to the transient analysis, the getting the current with respect to the time domain analysis. And now we just you see here the small signal analysis, basically depending on the x-axis on the frequency domain respect to the time or the current. This is the device or the circuit mixed mode simulation. This, in case of the mixed mode simulation, just going to is creating a single device and convert to a symbol basically, and just single device used for a circuit. And the rate tracing optical simulation, just for the solar cell and the photodiode, photodetector can be used for the ray tracing optical simulations for DC and transits also available. Now you see here, this is the 3D visualization. After just creating a device and you just simulate it, and after the see the results in the form of the 3D visualization, see here, this is the electron density. You see here at the channel length, The high concentration of the electron density is the surface of the channel. You see here, and this is the color representation line. You show here the maximum electron density is 1.76 e to the power 20 is the just like the red color show here. Same here, this is the doping at the source and drain, just like a fin-fat structure. This middle one is the channel, and this one is the source, this one is the drain. The high concentration of the donor doping, 1 e to the power 20, you see here. At the depth of this doping, just reduce it and change the color. You see here. Now, these are some result extractions, like just the linear versus the log plot. At the x-axis is the gate voltage, just like so here. This one is the linear, and this the saturation. Red one is showing the saturation, this one is showing the linear. And at the y2 axis, you just show here the log plot of this is the same linear plot. Next is showing here the cutoff frequency with respect to the voltage. These are some of the result extraction of this completed simulated device. This is basically a TGF factor and transconductance, and this one is the gate oxide capacitance with respect to the voltage. Now, these are some of the important parameter extraction after the simulating the device. The transconductance, how to calculate, which formula can be used in the TCAT tool. The transconductance generation factor, can how to calculate output conductance, how to calculate intrinsic gain, early voltage, cutoff frequency, gain frequency product, transconductance frequency product, gain transconductance frequency product, gain bandwidth product. These are some of the advanced level formulas for use to complete demonstrate the device in the research paper. These are some basic designs used and creating a TCAT tool. Basically, this one is showing here the L-shaped junctionless FET transistor. This one is showing here the tri-gate FinFET structure. This one is the gate all-around structure, just like a dumbbell. And this one is the FinFET design, creating a layout.